In this video, we are going to talk about some of the basics of statistics. So first off, we're going to talk about the two major areas of statistics, and that is descriptive and inferential. So first off, descriptive statistics consists of methods for organizing and summarizing information. So some of the methods of descriptive statistics include things like making graphs or charts or tables from graphs, and then calculating various descriptive measures such as averages, measures of variation like the standard deviation, and percentiles. Right? So here we're just basically describing the data. Okay. Before we start talking about the second part of statistics, then or the other part, what we need to do is talk about the difference between a population and a sample. So a population is the collection of all individuals or items under consideration in a statistical study. All right, and then a sample is a part of that population from which information is obtained. Okay. So just say, for instance, just to illustrate the difference, say that you wanted to find the average height of all students who attend our college. Okay. So one thing you could do is just go out and measure the height of every single student in the college. That would take a long time, right? It would be difficult to coordinate everybody's schedule and get around to check everybody's height, but you could do that. It would just take a while to do that. Okay. So the population there in that study would be all of the students at Dalton State College in our particular semester here, fall 2020. So, all right, so that would be the population. Then the other thing that you could do is go take a sample of the population. So in a sample, you wouldn't take measure everybody's heights. You would just pick some people from the population as a whole and measure their height. All right, and so that would be a sample. So population is the collection of all individuals that you're studying, and a sample would be some smaller part of that. Okay, and it's much easier to take a sample. Okay, and it costs less, takes less time, right? And so some populations are so big that there's no way that you would be able to get information from every single person in the population. So one of the critical things about statistics is whenever you take a sample, how well does it reflect that population? If you're not careful about how you take the sample and the methods that you use, you might get information that doesn't really reflect, the population at all. Okay. For instance, say if you wanted to find the average height of everybody in the United States, and you only went around and took a sample from players who play in the NBA, well then, the information that you get from that sample is not really going to reflect, the population as a whole, because players in the NBA tend to be a lot taller, right, than your average person, right, because that helps in the sport of basketball to be taller. Okay, you've got to be really careful about how you take these samples, right? And so the fundamental question that the other part, the inferential part of statistics, tries to answer is how reliable are conclusions made about a population if you only take information from a sample. Okay, and so that leads us into inferential statistics, right? That is the branch of statistics that is concerned about methods for drawing conclusions about a population when you only take a sample. Okay, so how well should that sample information reflect the population information? So there are some methods that we will talk about in this class, basically confidence intervals and hypothesis testing. Okay, and we'll talk much more about that later on in the course. All right, so next thing that we want to talk about is classifying statistical studies as well. You may have heard these terms before. First off is a descriptive study. A statistical study is called descriptive if the purpose is only to examine or explore information just for its own intrinsic interest only. Okay, so you just go out and collect this information, and then you just examine the data and see what it looks like. So, for instance, here are the final results of the 1948 presidential election, and you can see the people that were on the ballots, and this is the popular votes. Okay, this actually is a little bit of a famous situation because there is a Dewey defeats Truman, and in this picture you can see President Truman, who won that election, holding up the Chicago Daily Tribune, and it says Dewey defeats Truman. Okay, and so they published the wrong results from the election, and one of the reasons is that they had the way newspapers worked. I don't know if they still work that way, but back in this time in 1948, they had to print those on machines, and so there was basically a deadline, and the election wasn't over with before that deadline, and so what they did was went to a guy who had predicted those the presidential elections pretty accurately before, and so basically he was taking a sample of the votes, and everybody based on that sample concluded that not only was Dewey going to win, but he was going to win big time, and it actually turned out to be the other way around. Here you can see the final results, and so this newspaper was so confident on that material they published this incorrect headline here. So that's a pretty famous example of where not taking a sample correctly leads to some incorrect results. So, all right, so that's a descriptive study. All right, a study is called inferential if the information is obtained from a sample of the population, and then the purpose is to study and that information and draw conclusions about the population. Here you can here's a reference to a inferential study done in baseball. So in 1977 baseball MLB season, Major League Baseball season, the pitchers complained that the new baseballs that they were using in that season were livelier than the baseballs from the previous year, and because home runs are up from the previous year. All right, so in a particular season, right, there's about 360,000 baseballs that are used by Major League Baseball. So that's too many to test out, every single baseball to see if it's livelier. So what they did was take 85 baseballs, right, and then test those in a lab to see if they bounce more than the other balls when dropped from a certain height. Okay, and so that's an example of an inferential study. Took a sample of 85 baseballs and going to look at their characteristics and see what you can say about the population of baseballs. And the results of that were that the new baseballs were, in fact, livelier than the previous years, but still within the Major League Baseball rules there. So that's an example of an inferential study. You're taking a sample and studying the sample to make some conclusion about the population. Right. A study is observational if researchers simply observe characteristics and take measurements, as in a sample survey. So in this study, a retrospective cohort study of vasectomy and prostate cancer in U.S. men, that's published by the Journal of the American Medical Association. So what they wanted to know is there a relationship between vasectomies and prostate cancer? So somebody probably, a doctor probably started reporting on their findings and studied and said, hey, is there some connection between these two? Do vasectomies and cancer have some relationship? And so then what they did was kind of sit down and start recording all this information about patients who had vasectomies and their rates of prostate cancer versus men who didn't have vasectomies. and just kind of compare the rates of prostate cancer. All right, so that's observational. The two groups, they're just observing them. There's no treatments applied to the men or anything like that. And so the results here are about 60% elevated risk of prostate cancer among men who had a vasectomy. So the men who had vasectomies, out of 22,000 that they studied, 113 had prostate cancer, whereas those men that didn't have vasectomies, about 70 out of 22,000 had prostate cancer. So you can see that the results for the vasectomy group is higher. Again, about a 60% elevated risk of that. Okay, so that's an observational study. And a little bit later we'll talk about correlation versus causation, right? And the issues out of that. Just because this number is higher doesn't mean that vasectomies cause prostate cancer. There could be many other factors involved, okay? You have to be very careful about that. One other thing that inferential statistics will do will tell us about the differences in population. We can see that this number is higher, right? 113 out of 70. But one of the things inferential statistics also does is allow us to tell differences, whether differences in numbers are how rare they are, basically, as well. So we'll talk about that much later in the course. All right, in a designed experiment, researchers impose treatments on different groups, control treatments and controls, and then they observe the characteristics and take measurements. Okay, so in this study, prevention of the first occurrence of neural tube defects by paraconceptional vitamin supplementation, that appears in the New England Journal of Medicine. So the question that they want to answer is, does prenatal consumption of folic acid help reduce the birth defect rate? Okay, and so here, what they did, right, is split women into two groups. Okay, so one group took folate acid supplements, and one group did not. Okay, so here they are imposing a treatment, right, on one group and the other. So that's what the researchers set out to do. In the previous examples, researchers just observed; they didn't impose any different treatment on the men. But here they took the women that were involved in the study, split them into two groups, and gave one group folic acid and the other group no folic acid. And the results here were that the birth defect rate was reduced in the group taking folic acid. There was 13 birth defects out of 1,000 versus 20 in the folic acid group, and about 23 out of 1,000 in the control group. Okay, so here the groups, the individuals in the study were split into two groups and had different treatments. Okay, so that's a designed experiment. All right, so that is a small classification of statistical studies, and one thing that I want to stress, if there's one thing that you come away from in this class, and it is extremely important that you realize this fact here, and that is that correlation does not imply causation. All right, when you do an observational study, you observe, like in the case of the vasectomies and prostate cancer, right? Those kind of studies can only reveal an association or correlation. Okay, it doesn't mean just because the rates of prostate cancer were higher in the men that had vasectomies, that does not mean, right, that having a vasectomy causes prostate cancer. That's an easy conclusion to jump to, but is absolutely bad and invalid reasoning. Okay, it's extremely important that you, as in whatever field you're in, realize that the mistakes involved with jumping to those kind of conclusions. Okay, you might, in that case of the vasectomy versus prostate cancer study, you might all the doctors might have rushed out and said, don't get a vasectomy at all because it causes prostate cancer, and that would be absolutely false. Okay, there's many other different links that are factors that could be involved with causing prostate cancer. Only designed experiments can help to establish causation. In designed experiments, they try to control for those other factors in there and try to narrow that down. So if you have a lot of these designed experiments, that can help to establish causation. Okay, like in the folic acid study. All right. So one conclusion that you see people jump to over and over again, right, is just because there's a relationship between two variables, that does not mean that changing one of the variables will result in changes in the other factor. Okay, so just because there's a correlation, there's some relationship, does not mean that one thing causes the other, as in the case with the vasectomy study. All right. Down here is a quote by Stephen Jay Gould. He was a biologist, and it says the invalid assumption that correlation implies cause is probably among the 2 or 3 most serious and common errors of human reasoning. So just to illustrate that point some more, I'm going to show you a couple, actually 4 different cases of that. A couple are silly, and a couple kind of directly relating to you and our college. All right, so the first one, ice cream causes murder. So an observational study, right, shows that when ice cream sales are high, murder rates are also high. All right, and you can see, follow this link to here, and it goes to this article which talks about the observational study. So when ice cream sales rise, so do homicides. Coincidence, or will your next cone murder you? All right, and here it talks about the article in the New Orleans Times-Picayune attempting to answer a question: should ice cream be blamed for murders? All right, so in that observational study, right, they noted that when ice cream sales are high, well, then murder rates are also high, and that is absolutely true. Okay, that there's some correlation, right, between ice cream sales and murder rates. All right, and that's correlation, right? But remember, correlation does not imply causation, right? Ice cream, just because people are selling ice cream, doesn't cause the murder rates to be higher. All right, there's other factors involved in there, and most likely, right? I mean, one of the factors, just to give you an example, is that you probably sell more ice cream when it's hotter outside. When it's hotter outside, then in the summer, right? For where we live, people are out more longer during the day. You can stay out longer. It's warmer, so people are moving around. When it's cold outside, people spend more time indoors. So that's one of the issues that could account for the fact that when ice cream sales are high, murder rates are also high. Right? So again, banning ice cream sales is not going to make the murder rates drop. Okay. So then another one that's this one is kind of just a joke. It says an observational study shows that the number of pirates have decreased over the years and the global average temperature has increased. So if you look at on this link, you'll see this chart, and if you look at the chart, right, you can see in 1820 there were 35,000 pirates, right, and then the global average temperature in Celsius was between 14 and 14.5. And here, as we go down, the number of pirates are dropping. In the year 2000, there was only 17 pirates, and you can see that the global average temperature in Celsius was almost two, or a little bit more, right, than 2 degrees higher than it was in 1820. All right. So as the number of pirates are decreasing, the global temperature is increasing, and that's probably pretty close to the truth, right? Probably way more pirates back in 1820 than there are in 2000. So that's correlation, right? There's some correlation between the two. So that would say, hey, if we causation, right, would be saying, hey, if we increase the number of pirates, right, people start being a pirate, it will fix the global warming issue, and the mean global temperature will go back down, right? So that's causation, and anybody will realize that's just uh, completely untrue, right? Just because we have more pirates does not mean that there is causation between those two factors. All right, so that's the difference between correlation and causation. All right, there's a couple of other ones, and these are, to me, a little bit more seriously because they affect people at our college, right? The first one is with Complete College America, right? So they have an observational study, and they find that students who take 15 credit hours during their first semester in college are more likely to graduate, right? So, and I believe that. That's probably true, right? And so the recommendations are that we force everybody to take 15 hours during their first semester of college, and that will make the student more likely to graduate. So this first one, again, is correlation, right? There's some correlation between students who take 15 credit hours their first semester in college and those that graduate, right? The more likely somebody is to graduate. So there's some correlation there. But just because you force everybody to take 15 credit hours during their first semester of college, right, does not increase their likelihood that they're going to graduate. And so here, if you go to this link, you can see and scroll down, right, you can see the Complete College Georgia website. And after looking through it, it does look to me kind of like they backed off. It's students who take 15 credit hours each semester. So that's fine. One of the reasons is probably, right, if you can take 15 credit hours, right, then you're probably not working a full-time job as well, or have other responsibilities like a family or anything else like that. Sure, those students who are able to take 15 credit hours, that means maybe they have less responsibility, okay, than those students who can't do that, right? And it could be those other responsibilities that interfere, with them taking college, and they just can't help it. They have to work to bring money home to their family, and so, they're not going to be able to take 15 credit hours, and that might interfere with their ability to complete the degree as well. So blindly forcing students to take 15 credit hours during the first semester, in the hopes that that's going to somehow increase their likelihood to graduate, is invalid, flawed reasoning. Okay, it's not understanding the difference between correlation and causation. All right, and so the last one really made me mad. In this study, this is go to a more expensive college to be more likely to graduate. Okay. So this observational study finds that the more affordable a college is, the more likely it is that the graduation rate will be lower. And so it appeared here on this website, Market Watch, which I believe is run by the New York Times, or not New York Times, sorry, the Wall Street Journal. And and our college is mentioned in this. So if you look at the study, right, you'll see this is 2011, right? At that time, Dalton State College had an 18.1% graduation rate at that time. Okay, and it was one of the 10 most affordable public colleges in the United States at that time. Okay, and so you can see their conclusion in this article, right, is that if you go to a more expensive college, you'll be more likely to graduate, which is complete and total hogwash, right? It is not true at all. One of the things going on in Dalton at the time, right, was the recession. There was super high unemployment at that time, and Dalton was one of the most affected communities in the United States. So you don't think that had some issues, right, with not graduating and the default rate at that time. So there were a lot of other things going on. Just going to a more expensive school is not going to guarantee that you graduate. In fact, right, if you have other things going on in your life, you might be more likely to seek out an inexpensive school, right? If you don't have a lot of money, then that could affect your ability to stay in school, because again, you have to work a lot or do other things like that. So just because there's some correlation there does not imply causation. If you make the college more expensive, right? The students are going to be more successful. That's just not true at all. So anyway, this one really made me mad, and there's a comment down here that I really like. If you look at it, this guy understands. It says, "Wow, what a terrible article, and an illustration of stupidity, totally clueless. Could there be any other reasons for students of Ivy League schools to graduate and not default on loans compared to the poorest students in schools? Are you kidding us? How long did you spend researching and writing this garbage?" All right, so this guy is my hero here. And he understands the difference, right, between correlation and causation, whereas the people who are responsible for this article absolutely did not. So, all right, so that's it for this section 1.1. The homework problems out of the book are here, 7 through 21, and those are just about classifying different types of statistical studies.